Hi, good evening. It's night for me, so I'm very happy to be here. My name is Charlie. I'm a French senior software engineer at TODO, which is a startup based in New York, and I'm in Rome right now. And I'm very happy to be here online with you because I'm totally a fan of GraphQL for many years. So let's get started. So as I said, I'm Charlie, senior software engineer at TODO. And I started to use GraphQL 4 years ago, so 1 year after the public release. And I immediately started to do side projects, like, for example, the GraphQL API of Spotify, REST API, as a side project using Express, etc. And also, I immediately started to use GraphQL in professional application, in production applications with React. And after 2 years of usage on different type of projects, I decided to write a feedback on a blog I do with friends that was called Why Use GraphQL Good and Bad Reason on Honest Engineering. And the purpose of this article was to provide a good feedback to people in terms of adoption on whatever was the good and bad reason to use GraphQL. And there was three main advantage of GraphQL at that time. First is that GraphQL is good to build smooth user experience. First, because of the ask for what you want ideology, which is based on the language itself that lets you get the data that you want, only the field that you want, but also in the same HTTP request. So it was reducing the overhead in terms of network on both the size of the payload, but the number of exchange that you do with the API. So this was very, very good for mobile-first experience, but also on the optimistic UI features provided by the client. So first, for example, by the optimistic UI on the mutation, so optimistic responses, as we call it. So being able to update the local, what is displayed on the UI before having the answer from the server, from the API, but also the different fetch policies provided by Apollo. The second one was GraphQL is good to solve data complexity issue on the front end. So if you were working with big SPA in the past, or even now using REST API that provide only endpoints for models or for maybe relationships, you will have to query a lot of APIs and all the crunching of the data on the client side, and maybe eventually put this data in a cache, like using Redux or maybe Mobix tree. And all this is solved by, on one side, GraphQL itself by design, because GraphQL queries and mutation allows to provide an API that is not directly linked to the models as a one-on-one relationship, and also by the client that provide a very powerful cache using observers, either on Relay, on App or Apollo. Also, things that I find interesting is that the mutations are like typed and checked also on the client side, so you don't have to duplicate anymore the very basic check that you have to do, which are the same as the API. The last point 2 years ago was really, really, really edgy, but it was like using GraphQL for microservices orchestration. So being able to do microservices orchestration, so having multiple GraphQL API and plug them together using Apollo schema stitching, which is now Apollo Federation with way better features and more advanced. The thing is that if you ask to someone today why they use GraphQL, it's very most likely they're going to answer something that's going to fit in those three reasons. And I found that it's kind of a shame, in quote, because GraphQL brought a lot of things outside of just the scenario of front-end fetching data from the API. So today I want to talk about GraphQL, the fact that GraphQL is much more than an efficient way of fetching data from the client side. So in order to cover the subject, we're going to take a look at 4 examples of innovation that GraphQL brought in the web ecosystem that are not linked to only front-end fetching data from the backend. So first, GraphQL as application state management. So nowadays, if you build like a React app application, you have to handle top-level state management, like that have to be shared in the whole application by all components. it's very most likely your choice is going to go on three main solutions. Either you're going to stick to React itself and use Context API if you have a very simple state that can be based on context, or either you're going to use Redux, which is like for a very long time now, or MobX. The thing is that if you think about GraphQL, GraphQL is a data query and manipulation language for API. But what if your state, your local state, your application state behave like a local API? This is exactly what the team from Apollo thought 2 years ago. They made like a kind of a POC that was a separated package that was called Apollo Link State, and that is not now part of the core Apollo client. And this feature is called Apollo GraphQL Local State Management. So let's take a look at what it means and what it brings and how it benchmarks compared to the major solution that exists today. So we have a query. Here, this is a GraphQL query that lists a set of alerts because we have an application and we want to list alerts. Alerts, in order to get alerts, we need to provide a workspace ID. And here, you can first notice something very particular that you don't see in regular Apollo or Relay usage, GraphQL usage. This client directive. And this client directive is here to say to Apollo that this data has to be fetched locally. It's not from the API. Here you can see something great that is bringing Apollo, is that you are using one language, which is GraphQL, and also one set of hooks or API, JavaScript API, to handle all your data, either it's state or remote data. And if you look closer, you're going to see that here, workspace ID is actually exported as a variable to be used as a variable for the request that we do, the query that we do remotely. So just with this simple example, you see all the power of Apollo local state. So let's see quickly how it works. So if in your local state you have like what we call scalar values, so very simple value like Boolean, string, etc., not objects, you can actually query those values if they exist in the cache without having to write anything in terms of configuration. And if you want to update those values, you can use or initialize the state as starting at the start of your application. You can just use a client instance of Apollo.WriteData. So very simple. For real use case, of course, you're going to have complex value like object or custom types, so or computed value. So for that, it's going to be a little bit different. So here, for example, we have a preferences object that gets the preferences from the user, dark mode, language, notification, etc. For that, you're going to have to provide local resolver that you're going to implement on your web application for mutation and queries. So let's have a quick look on that because I want to show you that it's really easy and there is nothing hidden in terms of complexity. So here, those preferences are stored using local storage. So on the right, on the left, you have the reference query. So it's very simple. It's a simple object. And here you're going to see that we have this. This is the Apollo client configuration. We have our cache. We have a resolver object. And then we have the custom resolver that we have to provide for a query and the mutation. So for the query, we're going to get the value from the local storage. We're going to parse it if it exists. Very interesting thing in here in terms of performance, small tips. This resolver is actually only called once to iterate the cache, and then further call will be calling the cache only. That's why, for example, the mutation that could be called from anywhere, any component from your application to update the preferences is updating both the local storage and the cache, because Apollo is going to rely on the cache and not calling the resolver every time. Very important point for performances. Okay, so here we just add a very fast view on the fact that Apollo is not providing like top class features in terms of local state management, and it's a real competitor to MobX and Redux for the main reason that it has all the local state management capabilities. First, the state is managed by Apollo Cache, like it's already managing your data that you use with GraphQL API. If you have computed value, which is part of the proposal value for MobX, for example, you can use local resolver. As we just saw, it's very simple. If you want to have actions, if we take like the analogy with Mobix, then it will be mutations or writing directly in the cache using client.write query. If you want to react to some changes, then it's again out of the box, because query in Apollo are based on observable, which are called observable query. So if a query is using a part of the cache that has been updated, even if it's a local cache, it's going to be updated. And finally, the cherry on the cake is that since you're using Apollo, this local state is going to be inspectable, and all the query that has been done, that even for the local state, are going to be inspectable, and you're going to be able to debug them using the Apollo Client Dev tool. So that's all for the state management. Let's now stay in the front end, but on another subject, with another innovation in the GraphQL landscape, but in the web ecosystem on the front end, which are GraphQL generation powers. So when the GraphQL specification and the public release was made, I was really interested into the GraphQL introspection, and I was thinking for a long time that it was one of the most powerful but underrated features of the language, and maybe misunderstood. It was not super well explained in the documentation what could be done with it. And the thing is that in the last years, we had a rise of, almost at the same time, of TypeScript and GraphQL, and a real passion for the JavaScript ecosystem for types. And this brought a lot of projects using GraphQL introspection for generation. One of the most famous projects that we have right now, that is a link between TypeScript, or that is around generation when it comes to GraphQL, is GraphQL Code Generator. So given a GraphQL schema, it's going to provide a set of tools to generate all the TypeScript types for you, but also generate code, which is super impressive, because you can generate the React Apollo hooks for you and the associated types. So which prevents you to have all the boilerplate that you have to write all the time, which is quite repetitive. And it works also for other libraries, or not only Apollo, like URQL, and for other types like Flow, Java, Kotlin. So here we have a schema. So we have a schema when we have a query. The only query is me, that allows to get the current user, which has user type. And here, just below, you have a document which is used on our application, a current user query. And this is the generated code. So we have all the TypeScript types, the user types, the type of the query, and then we have the hooks generation. And then in our application, we're going to be able to use the use current user query hook in order to query the data. In our application, we won't have to manage all the complexity to maintain the types and also to bind them when it comes to, for example, providing the generics, etc., etc. It will be automatically generated, very easy to maintain, and very strong, because always depending on the real schema definition of the data. Another more advanced, different, but quite linked, similar example of usage of GraphQL introspection power is a library that allows to do GraphQL query without actually providing a query. So GQLS is a project that, as you can see on the left, we have code, we have just a user component, and every component is wrapped into a GraphQL function. And here we have a global query value. It's not really global, but it's like local query value. And basically what it does is that it looks at all the properties that have been used below query, inside query, and infer what is the GraphQL query that needs to be called. So this is another example. It's not production ready yet, but it's kind of show also the different kind of thing that you can do with GraphQL. And on a side note, I also had my kind of fun times with GraphQL, and I did a library that allows to generate React from given GraphQL mutation, because since we know what kind of data we can provide, we can remove a lot of boilerplate, especially when it comes to forms. So here, for example, we have Frontier, which is the name of the library. We have a UI kit, and UI kit is just an object that defines for each GraphQL type what is the component to use, we have the Apollo client, we have the mutation, we instantiate the component, and it creates the form. And this is only working because of the GraphQL language, because it's typed and easy to introspect. So to sum up, GraphQL special power introspection brings us stronger type, a bootstrapping of client configuration, and overall better developer experience. Okay, let's now totally quit the front end and talk about what GraphQL is bringing right now to the backend world by seeing a use case of GraphQL for backend to backend. So when we talk about client server, most of the time people think about like, okay, client is front end and server is backend. But in fact, in the real world, we can have backend calling other backend, and this is why I call backend to backend. So I want to share with you a story I had in my previous work at Algolia when we used GraphQL to have a more flexible architecture. So Algolia is a search API services. So we store some data in order to put them in search indices. And we add an integration with Shopify, which is like an e-commerce platform, and store data about like products and inventory. And we add an indexer that was taking all the product and put them in Algolia. And when we were indexing those products, we needed to make requests to the Shopify API in order to get meta properties called meta fields. And then this for each product. The issue that was that the Shopify REST API was rate limited. And it was what we called request-based limit, meaning that we could do maximum for each shop 2 requests per second. And this was becoming a very, very big issue for us in terms of performances, especially for big clients or for clients that have like a lot of flash sales. So we needed to have another solution. So we started to look at the Shopify GraphQL public GraphQL API, especially because they have a very different kind of rate limiting by design, thanks to the structure and the types and the way that GraphQL is working. And what they provided is a different, what we called calculated query cost rate limiting, where when you do a query, you had to count, you have 1 point count for every field that you query in your query. And then the rate limiting was like, okay, you can use 50 points per second. So let's have so we decided to give a try to this. So let's take a look. Here we are getting a product from Shopify, and so as I said, each field is 1 point, but when you nest, the nesting is a multiplicator. So what does it mean? Here, for example, we have 1 point. What is the cost of this query? 1 point because product.id, and then each meta field has 4 properties, so it's 4 points, but we are getting 10 of them. So it's 10x 4 plus 1, 41 points. So we do this query and we get this answer. So we get the data, of course, because it's still GraphQL. And here we have a product, and this product, in fact, had only 1 meta field. And besides data, we add this extension that provides some information about the current state of the throttling. And basically, what Shopify said is that, okay, the maximum cost of this query, by definition, the static cost was 41, given the number of field theoretically you could get. But in fact, there was only 1 meta field, so the cost was 4 property of the meta field plus 1 of the products of 5. So this query actually costs really 5 points. And by the way, this is your throttling status right now. So this for us was very, very, very insightful, because we were able to build what we call the flexible throttling indexing system using this GraphQL API. And the algorithm in the big line was the following. For each customer, we add the number of points assigned. We'd add a maximum, for example, to say, as we saw, of 1,000. So every time we had to index a product, we look at the score, we compute the query static maximum cost, and we see if we have enough points. If we can, we do the query. And then after each query, we update the shop score with the actual real cost of the query. And this system allowed us to go from 4 products per second to 10 to 50 products per second. a lot of other companies are switching to public GraphQL API and provide this calculated query cost rate limiting, which is more flexible. Shopify is one of them. There is also GitHub and Yelp. So GraphQL brought also innovation in the backend to backend. What are the main takeaways? So as we saw, there is this use case, for example, of having new kind of design of API, and especially when it comes to rate limiting because of the type system and because of the thanks to the granularity of the schema itself. But also, there is another thing I didn't have time to talk here. It's also GraphQL, when used in the backend to backend, helps to build more maintainable data pipeline because we can have abstraction of what we query, especially thanks to a new project that just arrived, which is called GraphQL Mesh. And GraphQL Mesh is a project that allows you to query with GraphQL any type of API, either it's GraphQL, gRPC, Swap, or Swagger, which is REST. So this is super nice because you don't have to worry about anything about the implementation of the API that you query. You're just using GraphQL to query anything. Okay, let's wrap up on the last point, on the resolver-less GraphQL, still on the backend. So what is the common point between GraphQL and SQL, except they are like off by one letter? The common point is Ashura. So I know it's not a new project, but I think it's still a huge innovation in backend and servers. So Ashura is not a product, but it's an open source project that translates GraphQL abstract syntax tree, so queries, into SQL abstract syntax tree, AST, on the flight, meaning that it's not generating resolver, it's not generating code that then run SQL. It takes GraphQL and translates it to SQL directly. And this provides super fast execution of query, and it works out of the box on existing database. So you're going to say, okay, yeah, it's nice. It's super nice to do like small tests, some small POC, but it's not enough in terms of feature. I'm pretty sure it's not stable. That's not true. Actually, Ashura is very stable. It's used by a lot of very big companies. It's very good in terms of performance. It provides also access control list support, advanced authentication authorization using GWT, remote schema support, meaning that you can compose with Ashura. You can query a Ashura instance server and having it plugged on many Postgres instance, but also many other GraphQL API. So this is super powerful as one kind of Apollo federation over Postgres. It supports subscription, which is not the case of Apollo federation for now. You can trigger webhooks, and bonus, Ashura provide one-click install on most cloud provider, AWS or Heroku. So let's have a conclusion of those innovations. GraphQL is definitely more than just a front-end query APIs, language, and libraries. First, we just saw that Apollo GraphQL, and I heard soon, at least Relay is considering also doing it, is reliable for local state management. It's very, very powerful. GraphQL is bringing a lot of flexibility when it comes to backend, and it's only the beginning because not that much company migrated to public GraphQL API. GraphQL introspection brought a lot of tool on front end when it comes to TypeScript generation, types generation, code generation, and I'm pretty sure we're going to have way more use case that's going to improve the developer experience. And then we can even have now GraphQL without having to write the resolver that works out of the box on existing database or existing schema, or you can even use GraphQL for anything using GraphQL Mesh to query any kind of data. Thank you very much. You can find me. So I hope you liked the presentation, that you learned something about GraphQL, that you are as excited by me as me by GraphQL and what it's going to bring in the future. You can find all my you can find the slide on my notice profile, also all my previous presentation. Follow me on Twitter if you want to. And also I'm going to write some articles about GraphQL soon especially one of the on this presentation, but with way more information. Thank you very much.
Well, Charlie, that's wonderful. Thank you so much for your time. I know it's pretty late in the night as well over here, so thanks so much for spending the time for us. I have one question here from Aman. Can we use Apollo GraphQL with Vue for state management in the client side? Thank you, he says.
Let me check. I don't have the answer. I guess it's written in the doc. I'm not sure. I will have to check. Yeah. So, okay, I'm on the doc. Yeah, apparently there is something. Yeah, you can use what they call local state with Apollo Vue. I'm not sure you have the same features as advanced, but yeah, it exists. Yeah, apparently it's exactly the same as Apollo React. It's the same core. So yes, you can.
Okay, and somebody else is putting a note here. Can't wait for your articles. That's the thank you again. Yeah.
Thank you.
And Amin says thanks as well. Let me just give it a minute to see if there are any more questions or follow-up questions.
Yep, of course.
While we are waiting, I'll ask one question.
Yes.
If I am absolutely new to this and I'm considering whether to use it or not, what would be some situation where maybe I should rethink about using and not jump into using GraphQL?
So what kind of you want, like, example of what would be the usage of?
Yeah, is there a reason I shouldn't use it at any time?
I would say the bad reason to use GraphQL is like thinking that it's going to solve all the performance problem, because it's not a feature of GraphQL. It depends on how you use it. So it's not like a magical thing. What else? I think it really depends also of the time you have to invest, I would say, because we have to rewrite a lot of things on the front end. But I think, I mean, Apollo team made like a really awesome work when it comes to have like a incremental adoption, because you can actually use you can use Apollo GraphQL clients to query REST API. It works. So you can have like a kind of a hybrid implementation when you have like part of your API that is like still in the old implementation in REST, and part of your API that is on GraphQL. But I would say that GraphQL, the hardest thing is that you have to rewrite your backend, which is super expensive. But there is a lot of tool that comes like GraphQL Mesh that allows you to put like a gateway in front of it. So I would say it really depends on your use case. I would say use GraphQL if you feel like that you're struggling with your state management, with keeping your data up to date with performances because of the state management, not because of your backend, even if it can help. Or if you feel that your front-end application, every time you load it, you're loading like half of your database in memory, because anyway, it's too complicated to really query what you need.
We have about 60 seconds with us. So one follow-up question. Does GraphQL is for both front-end and back-end development?
Yes. I don't know if I can give an example, but yeah, you can use, so definitely for front-end, yeah, it's made for front-end. It's made for front-end and mobile first. And on the back-end, you can use it in certain use cases, like I showed, if you have to query very complex set of data, and basically your back-end is like kind of lost in all the crunching of data, you can put this responsibility of crunching the data and doing all the mapping inside either a GraphQL gateway or the GraphQL API itself. So yes.
Very good. Well, thank you so much. Again, thanks for your time, and
thanks for having me.
Stay safe. Thank you.
Yeah, you
and
too.
Thanks everyone.
Bye.